Ooh, purple. Hello, everyone. Welcome to the Morrison Planetarium, here on the unceded homeland of the Ramaytush Ohlone, the original and current inhabitants of the San Francisco Peninsula. My name is Teddy, and I will be your guide to the universe. So, this show is a lot of fun because, unlike the shows that we had earlier today, this one is 100% live. So, if you came here for another dose of Diego Luna's soothing voice, I'm afraid you are stuck with me. But like I said, it's a lot of fun. We're going to be starting from right here on planet Earth, and we're going to keep going farther and farther out, stopping to see some interesting things along the way until we get as far as we can possibly see. And then I'll be sure to drop you off back here on planet Earth by the end of it. Don't want to leave you all stranded in space. But in order to get the show started, I do need to make my way to the control booth, and that is at the top of these stairs. So while I make my ascent, let me issue a few reminders. The first is that we want to keep this space as clean as possible for all future viewers, so we do ask that you please keep your feet off of the seats. And if you've managed to smuggle any food or drink in here, please keep it smuggled. Secondly, now is the perfect time to go ahead and silence and put away or even turn off any of those devices that you might have that emit light or sound. So that would be your phones, tablets, cameras, pagers, beepers, lightsabers, anything like that. Third, I don't know if you know this, but space is pretty dark, and so it will be rather dark in here as well. So as much as is possible, please remain seated for the duration of the show. If you find that you need to make an early exit for whatever reason, please head up the stairs and exit at the top, not at the bottom where you came in. So once again, if you need to make an early exit, please go up, not down. Lastly, our shows can be somewhat immersive, and in the past, some guests have experienced some motion sensitivity or dizziness. If you find that this is happening to you, never fear. Nothing in this dome is ever actually moving, so you can close your eyes for just a few seconds, and your brain should remember that you are seated safely here on planet Earth and not actually rocketing around in space. So, with all of that said, just waiting for the last few phones to be put away. I can see everything from up here. All right. So, with that, let's go ahead, sit back and relax, and I'll get our tour started in just a moment. That was the wrong button there. Sorry, folks. Let's stop. Okay, let's try this again. Sorry about that, everyone. So, gonna go ahead, just set everything back to purple. And making sure everything's actually set up correctly this time. Sorry for the delay, everyone. Okay, now we can start our tour. And we are going to begin our tour here at the International Space Station. The space station is maybe a little bit closer than you were expecting. It's only a couple hundred miles above the Earth, which means that if it was directly above our head, it would actually be closer to us than we are to the city of Los Angeles right now. But if it was directly above us, it wouldn't be there for very long because it's traveling incredibly quickly around our planet. It makes a complete orbit once every 90 minutes, which means that the currently 7 astronauts on board get to experience the incredible sensation of 18 sunrises a day. But this is very close to our planet in cosmological terms. If we're going to be traveling through our universe today, we need to keep track of just how far we've come. So I'm going to go ahead, put this yellow line there above the Earth, and we can see off to the right of the planet that yellow line hovering a little bit above the Earth. So that is our measurement of a couple hundred miles. So all of the astronauts in space right now are orbiting the Earth, but there is somewhere that human beings have gone before. Our closest neighbor in space, the moon. So let's go ahead and fly there together. 12 very lucky men got to set foot on the moon back during the late 1960s and early 1970s as part of the Apollo program. And they all landed on this side of the moon, the near side of the moon. There is no permanently light side or permanently dark side, despite what some bands would have you think. But we can see that part of the near side right now is lit up and part of it is not. So using the miracle of modern technology and the push of a button, boop, I'm going to light up the entirety of the moon for us. The near side of the moon is covered in a lot of these darker areas known as maria, and they are the hardened remains of ancient oceans of lava which were once on the surface of the moon. But as we go around to the far side, we'll see that there are a lot fewer of them here and a lot more craters. This is something of a mystery to scientists as to why all of the maria are concentrated on one side. So who knows? Maybe someone in our audience right now will be able to answer that question for us someday and come back to me with an answer as to why that's the case. I look forward to your return. But it has been over half a century now since any human being has landed on the moon. But everything going to plan, that should be changing relatively soon. So if we go and think about this, the Artemis missions are underway. Artemis 1 was launched last December, and it was a robotic mission which flew around the moon and tested the equipment that we will need to send people back. It was a complete and total success, paving the way for Artemis 2, which is currently scheduled for almost exactly a year from now, November of 2024, which will send 4 astronauts around the moon to do some further testing. And if that goes well, Artemis 3 is currently scheduled for December 2025, which will send astronauts back to the moon, including the first woman. So now we can see both the moon and the Earth. And to make it even easier to see, I'm going to go ahead and put up the orbital path of the moon here. This gives us an insight into just how far those astronauts have to travel. It's about 240,000 miles from the Earth to the moon, right at what I like to call the edge of comprehension, because our brains are not really designed to handle numbers in the hundreds of thousands, the millions, the billions, the trillions. But if we really think about it for a moment, we can kind of get our grips on the number 240,000. If we all piled into a big tour bus together and drove to the moon, that journey at highway speeds would take us 4 months straight through. No stopping to eat, no stopping to sleep, 4 months. But since we're going to be traveling those millions and billions and trillions of miles, we need a more useful measuring stick. So we're going to use the fastest thing in the universe, light. If I equip our tour bus now with a light speed engine, that 4-month journey now gets cut down to the much more reasonable 1.5 seconds. So we call the distance between the Earth and the moon 1.5 light seconds. If we go ahead now and look at the other big ball of light we're used to seeing in the sky, the sun, we can automatically jump a lot farther away. The sun is 8.5 light minutes away, which means that if I were to suddenly snap my fingers and turn the sun hot pink, a power I definitely have, we wouldn't know about it for another 8.5 minutes, because the light would have to travel that far just to reach us. But we're not the only thing going around the sun. There are plenty of other things as well, like, for example, the other planets in the solar system. Closest to the sun is the planet Mercury, and then second closest is the planet Venus. Then we have where we started our journey today, planet Earth, and finally, Mars. These are the 4 inner planets. They are all rocky planets, which means that you could at least, in theory, set foot on them. But some of them would be a little bit more pleasant than others. I would really strongly recommend not going to Venus. It is kind of a horrible place. But you could at least, in theory, set foot on them. Not so much with the next few planets. The 5th planet is the largest, Jupiter, and the 2nd largest is the 6th planet, Saturn. These are giant planets, mostly made out of the gases hydrogen and helium, and so we creatively call them gas giants. And then further out are the 7th and 8th planets of the solar system, Uranus and Neptune. These are also made out of gas, but heavier gases, and they're a little bit smaller, and so we call them instead the ice giants. But there are other things in our solar system too. Like, for example, this between the orbits of Mars and Jupiter is the orbit of an object called Ceres. And Ceres is a dwarf planet that is found between all of these objects, the main asteroid belt. Now, when I said the words dwarf planet, that rung a few bells in some of your minds, because what I'm talking about is the perennial fan favorite, Pluto. Now, Pluto, for those of you with keen memories, was until 2006 considered to be the 9th planet of the solar system. And you might be wondering what exactly it is poor Pluto did to get kicked out of the Planet Club. To understand that, I'm going to go back and talk about Ceres again for a second, because the 2 dwarf planets share a very similar history. Ceres was discovered on New Year's Day, 1801, and when it was discovered, it was thought to be the only thing orbiting between Mars and Jupiter, and so we called it a planet. But then in the years and decades that followed, we discovered more and more objects. We now think that there are somewhere around 1 million asteroids in our solar system. So unless we wanted a list of planets that was 1 million entries long, we needed a new category. And so Ceres was reclassified to being an asteroid. Similarly with Pluto, when it was discovered in 1930, it was thought to be the only thing in our solar system out past the orbit of Neptune. And that continued to be the case until 1992, when an object called Albion was discovered. And then, in the years and decades that followed, we discovered the Kuiper Belt. And so now, we can barely even see Pluto's orbit in all of this mess. So we needed a new category, and we came up with dwarf planet. So what exactly is a dwarf planet? A dwarf planet is something that, like a planet, orbits the sun, not another planet, and is big enough that its own gravity smushes it into a ball. But being a planet is a lonely job. You have to be traveling through space pretty much by yourself. You can drag a few moons along with you if you want, but objects like Ceres and Pluto inside these larger belts are far too popular for their own good. And so, they are dwarf planets. Now, some people still feel very attached to the idea of Pluto being a planet. But it is not the only dwarf planet in our solar system, as we have seen. It is there with Ceres and Eris and Haumea and Makemake, potentially up to a dozen objects. And it's not even the only exoplanet in our solar system. So I wouldn't feel too bad for Pluto. It's right where it belongs. I'm going to go ahead and put away the Kuiper Belt, though, because it does tend to clutter things up as we continue our journey. If we were now to look at how far we've come and travel on our Lightspeed bus from Pluto to the other side of its orbit, that journey would now take us 10 hours. But even out here, we can find a little piece of home, because we've sent robotic explorers out into the darkness. These are our 5 farthest traveling. In the order of their launch: Pioneer 10, Pioneer 11, Voyager 2, Voyager 1, and New Horizons. And yes, Voyager 2 did launch before Voyager 1. We're really good at naming things. And so these are traveling out of our solar system incredibly quickly. But despite the fact that none of them have, despite the fact that the earliest among them was launched back in the 1970s, none of them have yet gone as far as light can go in just a day. So now, as we begin our journey into interstellar space, things are getting incredibly far away now. The diameter of Pluto's orbit is 10 light hours, and the sun is the closest star to us. But the second closest, Proxima Centauri, is 4 light years away. But even out here, we can still find something familiar. This is the radiosphere, and it is the outer edge of how far our human communications have been able to travel into space. Radio waves are a form of light, and so since the earliest radio broadcasts able to escape the Earth were broadcast in the 1930s, this is about 90 light years in any given direction from the Earth. The question is anyone listening? Well, every one of these blue circles here shows us a star that we have found at least one planet orbiting. We've discovered over 5,000 of these exoplanets so far, and if we look carefully, several of them are inside of the radiosphere. So who knows? Maybe somewhere out there right now, someone's listening to Nat King Cole or watching I Love Lucy. Now, just like the Kuiper Belt, these blue circles do tend to clutter things up, so I'm going to go ahead and put them away. But it is time now to travel to the galactic level. Our galaxy, the Milky Way, is a large spiral galaxy, which means that it is made of these large spiral arms emanating out of this bright center where thousands of stars all orbit incredibly quickly around a supermassive black hole called Sagittarius A star. But if we look at it from edge on, it'll almost seem to disappear into the darkness, because the Milky Way is a lot wider across than it is thick. It's incredibly flat. But it is very wide across, 100,000 light years from edge to edge. So that means a round trip journey from one side to the other and then back again would take us 200,000 years. And 200,000 years ago is when human beings were first beginning to leave the continent of Africa. So it is very large indeed. But even here, we can still see that radiosphere, that little blue speck about 2/3 of the way from the center to the edge. That is the entirety of the human experience. Anything any human being has ever done is inside of that little speck. Pretty humbling. And as we continue on outwards now, we start seeing a lot more dots. But these are no longer stars. These are galaxies in their own right, hundreds of billions or even trillions of stars each. And if you look carefully, you'll notice that there's some patterns you can find here. The ones in orange are all clumped together. And then there are these massive empty spaces with only a handful of those blue and green ones between them. This is an interesting question, and we'll get an answer as to why the universe is like this later on. But one note here, I do have to be the bearer of some bad news. These are not their actual colors. The universe is not made out of cosmic skittles. These are instead classified by what survey discovered them, roughly corresponding to when we discovered them. The ones that are all clumped together are easier to find. And as we keep going farther on outwards, new colors emerge. First, this purple, and then these lighter blues and lighter oranges. These are much farther away, and they are much harder to find, and so we found them later. But now, the universe seems to have an overall shape. It seems to be shaped like a butterfly. But once again, I do have to be the bearer of some bad news. The universe is not actually shaped like a butterfly. This is instead due to our perspective here on planet Earth. We seem to be smack dab in the center, but as far as we know, there is no such thing as the center of the universe. Every one of these myriad of galaxies is constantly expanding farther and farther away from each other. And so everywhere seems to be at the center. But what's up with the butterfly shape? Well, if you remember, our galaxy is made up of those spiral arms of gas and dust, but it's not see-through. And so while it's very thin, we can look above and below it and see very far indeed. But if we try to look through it, not so much. So while we continue to try to develop the technology to pierce through those clouds, we are stuck with the butterfly. And as we keep going outwards, there are more and more galaxies, and eventually a new color shows up. A kind of burnt orange at the tips of the wings of the butterfly. These are no longer galaxies. These are ancient objects because we've time traveled in a way. We are now billions of light years away from the Earth. And just like when I snapped my fingers and turned the sun hot pink and we didn't know about it for 8.5 minutes, well, because this light has traveled for billions of years to reach us, we are seeing objects of the early universe. We call them quasars, and you can think of them as baby galaxies. Galaxies need to be able to cool down a certain amount in order to become a galaxy. These are still incredibly hot objects as they are coalescing into their final form. And so they give us kind of a toddler picture of the universe. But if this is the toddler picture, there must be a baby picture. And we can go one last step. We can head to the oldest light in the universe, the cosmic microwave background. This is the light left over from when the very first atoms formed about 380,000 years after the Big Bang. We can see almost directly in front of us, down at the bottom, a bunch of dark areas here where there were hardly any atoms that formed. And next to it, to the left, we find these lighter areas where a few more atoms formed. And these tiny little discrepancies at the beginning of the universe explain why we find those clusters of galaxies and those massive empty voids. Because atoms have gravity and they clumped together. And so the areas with slightly more atoms pulled atoms from slightly farther away, and then there was more gravity. And so they were able to pull from even farther away. And this process compounded over the nearly 14 billion year history of our universe, leading to those clusters. Now, there are about 380,000 years of history before this, but there's no light from then, which means that there's really only one place left for us to go, and that's back home. So, as we fly back through the universe, I want to point out that this is only a small fraction of everything that's out there. There's dark matter, a mysterious substance which doesn't seem to interact with light, but must be holding the galaxies together. And there's a mysterious force pushing the universe to expand faster and faster called dark energy. We call them dark because we don't know what they are yet, but we do know that they make up a whopping 96% of the universe, which means that every quasar, every galaxy, every star, and every planet that we have seen today is only 4% of everything that's out there. And sometimes that makes people feel a little small, but I like to think of it like this. We might be just one small pale blue dot, but look at everything we've found. And we know there is so much more for us to find, which is what makes this such an exciting part of human history. We are unraveling the secrets of the universe, and we can share them with each other like this. We can find awe in them. And who knows what it is that the scientists of tomorrow will discover for us from here on planet Earth. So, as we fly back past our intrepid robotic explorers, saying hi to our old friend Pluto, and saying hi to our new friend Ceres, and dropping on in to the third rock from the sun, the only place in all of this that we have discovered life, I hope you'll take just a moment with me to appreciate the eternal beauty of the cosmos. That is our show, everyone. Thank you very much for coming. Thank you. As the